But farmers' relationship with water isn't as simple as having either too much or too little. Drought and rising sea levels is causing more and more land to become saline or salty, and that's a threat to our global food security.
Plants just really don't like salty water, the vast majority of them. And that's because plants are basically made up of cells that are big water balloons, absolutely packed full of hydration. And when there's a saltier layer on the outside, it basically sucks them dry, causing their cells to collapse. Just like if you were to cut vegetables and sprinkle some salt on them, you notice they get all dry and wrinkly. That's what happens with living plants in a field. They absolutely hate it.
But some farmers simply can't avoid it. David Hoyle's land is low-lying and a stone's throw from the sea.
The climate is changing. We seem to get times where we get massive downpours of rain, and then we get prolonged dry periods. So what we need to do is start harvesting and collecting rain when it comes for times when it doesn't come. We're below sea level, so a lot of our ditch water is actually quite saline.
But David is among a group of farmers around the world that are experimenting with saline agriculture, changing the way they farm to embrace the salt.
What we're looking at is where we can use more salty water to supplement the fresher rainwater to irrigate our crops with. You see in the North Sea, just over there, there's a massive amount of water available to us. If we can be smarter with being able to use and harness some of that water, yeah, that'd be quite exciting.
But plants hate salt water. They find it so difficult to grow for a different range of reasons. How are you able to use that? What works?
So at the moment we irrigate what's called overhead irrigation. So we spray or have like a giant sprinkler putting the water onto the crop. If we use salty water, as you mentioned, they hate it. That might damage the canopy, might burn the leaves, scorch the leaves. So what we're looking at is other methods like trickle irrigation. It's on a tape and a little drip of water comes out of that tape and it's below the surface. So we would put the trickle tape 5 centimetres below the surface of the potatoes here, and the water would permeate through. So it never actually touches the leaf of the crop.
So the roots are more resistant than their canopy?
That's what we're hoping.
Okay.
So we're thinking if we don't scorch the canopy we need for photosynthesis for the plants to leave, if we can get around not scorching that off, can we still give some water to the roots? And is some water, even though it's a bit salty, better than no water at all?
David is working with Dr. Ian Gould from the University of Lincoln to identify which crops are more salt tolerant and to test just how much they can handle.
We've got an irrigation experiment where we're irrigating potatoes with different levels of salts, and we're constantly monitoring. We're monitoring the yield of the crop, whether there's any quality issues with the crop, but also in the soil. We're making sure that whatever we do isn't leaving a lasting legacy in the soil by damaging the microbial aspects of the soil or the soil structure. But we need to know how much we can get away with, basically, and salinity is a problem. And we're just looking at ways to adapt to it because we're kind of faced with increasing levels around the water in this part of the world.
To work out exactly how much salt soil and crop can take, 5 10-square-meter plots were irrigated with water of varying saline levels, from rainwater to the saltiest ditch on the farm. And the spuds are about to be dug up for the first time.
Look at that, just beneath the surface, buried treasure. Looking pretty good as well, because I think this is one of the highest salinity plots. And this is so important because it's not just about yield and seeing how you can get more out of less. It's also about making sure the quality is the same. There's no point in growing a product that no one wants to buy and no one wants to eat.
While there's still plenty of scientific analysis to be done with the crop and the soil, the first test will be a little bit more basic.
So let me just get this clear. Neither of you has ever tasted the potatoes as part of this experiment.
No, not yet.
Cutting edge chip-related science. That's my favorite type of science. I'm gonna go for a lower salt, see if I can get a baseline.
Yeah, that was no salt.
Yep, very good. I'll take a tray of those any day. And going in.
So that is the 4,000, so that's the saltiest water we've put on it.
if you weren't to have told me, I wouldn't have noticed the difference.
No. We're going to go back and get the whole results before we make too many assumptions.
Okay, you do your stats, I'll eat the chips. I think that's a good deal.
Good deal.